Today's lesson is an introduction to organic chemistry and alkanes. Organic molecules are any molecules that consist of carbon atoms in rings or long chains. They will often have other atoms, such as hydrogen, oxygen, and nitrogen, attached to them. Organic chemistry is the branch of chemistry dealing with these carbon-based compounds. Carbon oxides, or ionic compounds with carbon, are not considered organic. Many organic substances are part of the carbon cycle. Natural processes such as photosynthesis, digestion, and respiration involve organic substances. Fossil fuels, which are formed from decaying plant and animal matter, are organic compounds. We use fossil fuels to obtain heat or energy. We also use fossil fuels to make petrochemical products, such as antifreeze, plastics, and pesticides. The first type of organic compound we will be learning about are alkanes. These are the simplest of the organic compounds in terms of structure and naming. A lot of our work in organic chemistry will be learning how to name and draw these structures. Alkanes always have single bonds between carbon atoms. They are considered saturated because they have the maximum number of hydrogens for how many carbons they have. These are non-polar molecules and will have a molecular formula that is twice as many and 2 extra hydrogen atoms than they do carbon atoms. The first example is methane. Methane has 1 carbon. Carbon is able to bond to 4 hydrogens, so the molecular formula for methane is CH4. Since there is 1 carbon, we can multiply the number of 1 by 2 and add 2 more to get the number of hydrogens. As alkanes get larger, the prefix that we use changes. For each alkane, notice how the suffix "ane" stays the same. The prefix changes to show how many carbons are in the molecular formula. You will be required to memorize the prefixes for carbon chains between 1 and 10 carbons long. There are several ways that we can draw organic molecules. Here is a structural formula, a condensed structural formula, and a line structural formula. Please note the difference between the types of formulas because assignments may specify a certain kind of formula. These formulas are for ethane. Ethane has 2 carbon atoms and 6 hydrogen atoms. Here are the 3 types of formulas for propane, which has 3 carbons and 8 hydrogens. Here are the 3 types of formulas for butane, which has 4 carbons and 10 hydrogens. Not all alkanes have straight chains. Sometimes they have what we call branches. When this happens, isomers result, which are compounds with the same molecular formula that have different structures. As the number of carbon atoms increases, the number of possible isomers increases dramatically. Decane has 75 possible isomers. When we want to name alkanes, the first thing we need to do is examine the number of carbon atoms in the longest chain. We call this chain the parent chain. The parent chain can be bent or straight, so you should not assume that it will go straight across the way it has in the examples we have seen so far. The parent chain will give the main name for the alkane, but the alkane may have branches, which are carbon atoms or other functional groups that are bonded to the parent chain. We will be looking at different types of branches throughout this unit, but for today, we will stick with alkyl chains, which are carbon chains. The alkyl branches all have different names depending on how many carbons are in them. In addition to noting the name of the branches, we will also need to account for their location in our naming. To do this, we number the carbons on the parent chain such that the numbers of the branches are as low as possible. Finally, we write the IUPAC name. The name begins with the number of carbon each branch is connected to, followed by a hyphen and the branch name, then the name of the parent chain. If there is more than one branch, then they would be listed in alphabetical order, ignoring di and tri prefixes. Here is an example of how you would work through the naming process. This molecule has 6 carbons in the parent chain, so it is hexane. There are 2 branches on the left side, so numbering should begin on the left side. There is a methyl group on carbon 2 and an ethyl group on carbon 3. With the branches in alphabetical order, the name is 3-ethyl 2-methyl hexane. There is not a space between methyl and hexane. If you are instead given a name and asked to draw, you should begin by drawing the parent chain. In the case of 3-ethyl 2,4-dimethyl pentane, the parent chain has 5 carbons. Next, we would add the ethyl branch to the 3rd carbon and the 2 methyl branches to the 2nd and 4th carbons. Notice how the naming changes when there are 2 of the same type of branch. Instead of listing them separately, we list the number of each and then add a prefix of di in front of the branch name. The final step here would be to draw in the hydrogens to fill each carbon's octet. A carbon can have 4 bonds, so ensure that each carbon has 4 bonds by adding in hydrogens that are bonded to them. A final type of alkane is a cycloalkane. These are alkanes that have the ends bonded together to form a closed ring. Examples of cyclopentane and cyclopropane are shown here. Notice that the number of hydrogens is reduced from the regular alkane molecular formula. In naming cycloalkanes, we simply add cyclo in front of the alkane name. If there are branches, you can number the carbon atoms on the parent ring and identify the branches and numbers of the carbons that are attached to. Because a circle has no end, choose your numbering so the branches have the lowest possible numbers. Please complete the November 6th quiz.